Hi students, in this video we're going to learn how to multiply and simplify radicals. So you've already learned how to simplify radicals. In the last lesson, I taught you like when you have something that looks like, for example, the square root of 28, we can think about how 28 is equal to 4 times 7, right? And then we learned how that we were allowed to separate that into a product of radical 4 times radical 7, that these are the same thing, okay? And then the purpose of doing that, remember, was so that we could simplify. Square root of 4 was 2, and then we would leave radical 7 because it doesn't come out whole. So in the last lesson, basically we took the square root of one number and split it into a product of two different numbers so that we could simplify, okay? In this lesson, we're kind of do that property in reverse. We're going to see that when we start with two radicals, we can multiply what's underneath them to make it into a product of one radical, okay? So, for example, here's how that would be useful. If we had by itself the square root of 2 times the square root of 2, well, let's look at the square root of 2. It's an ugly number, but weirdly enough, when you take square root of 2 times the square root of 2 again, even though it's so ugly, it ends up just being 2. And here's the reason why. Uh, the property we just had on the last slide says that if we have two separate square roots like this, we will be able to write it as one product. But if we do that, 2 times 2 is just 4, and then the square root of 4 comes out to be 2. So that's one way that this property will end up being helpful. So we're going to take a look at this problem, and something that I want to remind you guys is that multiplication is commutative, so the order doesn't matter, right? Like 2 times 4 is the same thing as 4 times 2. They both equal 8. So remember also that when there's no symbol between two things, it means multiplication. So this is one long string of multiplication. So what I first want you to do is rearrange it so that the whole parts are next to each other and so that the radical parts are next to each other. Because what we're now going to do is we can multiply the whole parts together. 2 times 4 is 8. And our property that we just learned says we can do 3 times 5 also. So really, guys, you can go straight to writing it like this if you would want to. So you can kind of skip this step. But so what that shows is that basically we can multiply the whole parts together and we can multiply the radical parts together. Now notice the directions say multiply and simplify if possible. So what we would need to do now is think to ourselves, can this part be simplified? So can the square root of 15 be simplified, do you think? Well, we know it's not a perfect square, right? Because if we start to list our perfect squares, remember 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So 15 is not in this list, right? It jumps right from 9 to 16. If we were to think about the factors of 15, 1 times 15 and 3 times 5, also none of those are in the list, right? So we know that the square root of 15 cannot be simplified, and so this is going to be our final answer. Okay, let's try another one. So let's remind ourselves this means a -1, and let's go ahead and rewrite it first thing, because multiplication is commutative, so I can rearrange it and put -1 times 4, and then I can put times radical 8 times radical 2. So first thing I want you to just do is show me what that'll look like when I multiply the integer parts together and the radical parts together. So -1 times 4 is -4, and then I'm going to have times the square root of 8 times 2 is going to give me 16. Now, this is the cool thing about this one, guys. It's kind of what we were talking about back here. On its own, the square root of 8 is ugly, right? The square root of 8 is not a perfect square, so we know it's not going to be whole. Same thing with radical 2 on its own, it's ugly, right? The square root of 2, because 2 is not a perfect square. But look at, because of this property, when I put them together, 8 times 2 is just 16. And what is the square root of 16? It's just going to be 4, right? So what do you think the final answer to this problem would be? So it'd be like doing negative 4 times 4 now. And so that's just going to end up being negative 16 as our final answer. And so if we wanted to check our work, we could go punch all this in our calculator and it should just equal negative 16. Okay, so let's try another one. How can I first want to rearrange this, right? And put the integer parts next to each other. So 5 times 3, because my rule says I can multiply those parts together. And it says that I'm going to be able to write this square root of 5 times the square root of 5 as 1 radical. So show me what the next step is going to look like. So 5 times 3 just gives me 15. Radical 5 times radical 5, I can write it like this, right, as one radical, but then it's going to look like this. And what is this square root of 25? That is a perfect square. It's just 5. So don't lose your multiplication symbol in here, because what's our final answer going to be? 5 times 15. So that's going to give us 75. So looking back at this one, we want to rearrange it first, and then we go ahead and multiply. So this right here, I want you to take this one and show me what it's going to look like after I get it to this point. So again, I'm going to be doing negative 4 times negative 4, and then I'm going to be doing radical 15 times radical 12. But again, this is going to give me positive 16. And then I can go ahead and do the 15 times 12. And that is going to give me 180. So I'm going to have 16 radical 180. Okay, I want you to check if this is a perfect square. Does it come out whole when I take the square root of it? It does not. So, I mean, I can think about my perfect square list again, like 1 squared is 1, right? 2 squared is 4, 3 squared is 9, 4 squared is 16, and I can keep going here. 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. This is as high as we made our list the other day. 13 squared is 169. 14 squared is 196. 180 is not in there, right? But I mean, all you have to do is check square root of 180 and you'll see that it's not a perfect square, okay? But we do, so it doesn't come out nice and whole like our other ones. So this time we have to simplify this number. So you're going to start listing, doing what we learned recently, the factors of 180. So 1 times 180, just 2 go into it. 2 times what? Okay. So I want you to go through and list all the factors for me. And here's the list you should have ended up with. 180 has a lot of factors. So when we're looking to simplify, though, remember, we want to find a pair of factors that has a perfect square in it. And even more specifically, we want the biggest perfect square factor. What is the biggest perfect square factor that you see in this list? So again, be careful, guys, because there are a few of them, right? There's 4, there's 9, right? You can look back up at your list of perfect square factors that I listed for you. 4 and 9 are both in that list, but the biggest one is going to be 36. Remember, if you don't choose the biggest one, you're going to have to go through the simplification process more than once. So I'm going to keep this 16, and I'm going to rewrite 180 as 5 times 36. Usually we write the perfect square first, because now we're going to break it apart, right, into the square root of 36 times the square root of 5. You see if you know how to finish this. So I want to remind you, this means multiplication, right? So we're going to keep 16 the same. We're going to take the square root of 36 because it's just 6, right? And we're not going to take the square root of 5 because 5 is not a perfect square. It's an ugly irrational number. You can check in your calculator. And then we can just go ahead and do 16 times 6. So 96 times the square root of 5 is going to be our final answer. Now, if we wanted to check our work, remember, we could go punch all of this in our calculator. So we could do -4 times radical 15 times -4 radical 12. So -4 radical 15, make sure you get out of that, times -4 radical 12. And then we think the simplified final answer is 96 radical 5. Let's double check that they're equivalent. And they are. So we know for sure we did our work correct, that this is our answer. Okay, we're going to do one more. So you show me step 1. Step 1 is where I rearrange it and write the integer parts next to each other, and I write the radical parts next to each other, but I already know I don't have to write it separately, right? Radical 77 times radical 7, I can go ahead and write it as 1, right? So what's that going to give me so far? So the -3 times 8 part's going to give me -24. 77 times 7 is going to give me 539. Is this guy a perfect square? So just go punch it in your calculator and see if it comes out whole or not. So the square root of 539, not a perfect square, okay? So we need to check, though, again, can it be simplified? So start listing the factors of 539, 1 times 539, and so on. You list all the factor pairs. So there's not very many for this one. So out of these 6 factors, do you see any perfect squares? Yes, we do have a perfect square, 49, right? The square root of 49 is just 7. So let's go over here, leave -24 alone. Remember, we are going to take 539 and write it as 11 times 49 or 49 times 11. Normally, we write the perfect square first. Okay, so then you try and finish it from there. So I split it up, right? Because the square root of 49 is going to come out whole. So remember, again, this is multiplication. So I want to put those dots in here because I'm going to be doing -24 times 7, since the square root of 49 is just 7. I'm going to leave radical 11 because that's not a perfect square, right? Go check in your calculator. It doesn't come out whole. -24 times 7 is going to give me -168. So you should have gotten -168 radical 11 as your final answer. Again, let's check our work. Go punch this in your calculator. What does it look like to 1 decimal place? So -3 radical 77 times 8 radical 77. Get out of the square root, 8 radical 7. It's about that number, okay, -557.2 approximately. Let's check that this answer is equivalent. So what do you get when you punch it in your calculator? -168 times radical 11. They're equivalent. So I know for sure that this is the final answer. It's the most simplified version possible.